Welcome to Pre-Calculus Honors.
So this case is the same as the one before. We have denominators with linear factors again, but this time we have an improper fraction, meaning the numerator has a degree greater than or equal to the denominator, right? So here the degree for the numerator and of the denominator are the same. It may be that the numerator has a greater degree. In either case, if you have an improper fraction, then you have to start with long division to first rewrite your fraction, okay? So let's do long division here. Clearly we cannot do synthetic in this case because the denominator, the dividend, is not linear, okay? Right.
How do we know it's improper? It's just, if it's like, if we have a hunch it might be improper, if it's possible to be improper, you do it?
When the numerator has a degree equal to or greater than the denominator, okay? All right, so we're going to use long division here. Okay, so here we have x squared minus x as the dividend, and we have negative 2x squared, as the divisor, and we have 9x minus 4 here. Okay, that's the dividend. So negative 2x squared over x squared, we get negative 2. We multiply, we get negative 2x squared plus 2x. And when we subtract these, the first terms go away. 9 minus 2x is 7x minus 4. Now that this term is smaller than your divisor, so 7x minus 4 has a lower degree than this number, you're done, right? When your remainder is smaller than the number here, you're done. So this fraction that we were given now gets rewritten as negative 2, the quotient, plus 7x minus 4 over x squared minus x. This is just the fraction rewritten, okay? So this negative 2 is the quotient plus the remainder over this. Now we're going to decompose this part into partial fractions, okay? Okay, so we start with that fraction, 7x minus 4 over x squared minus x. All right. Rather than writing x squared minus x, I'll just factor it here. So it's x times x minus 1, right? So I have two fractions now that I'm going to decompose this into. The denominators will be what? X and x minus 1. Okay? Now, the numerators will be a and b. Okay? And I multiply everything here by the common denominators. So x, x minus 1, x, x minus 1, so on and so forth. X minus 1's cancel, x's cancel, and everything cancels there. So what do we have left? 7x minus 4 is equal to a times x minus 1 plus b times x. Now, I have to choose numbers to eliminate one of these variables. So if I substitute a 1 into the x, then this term goes away. So let's start with that. So if x is equal to 1, then 7 minus 4 is 3 equals a times 0 plus b, meaning b is what? 3. Right? What else can I substitute to make b go away this time? 0. So if x is equal to 0, then I get negative 4 is equal to a times minus 1. So a is equal to 4. Okay? And now I'm pretty much done. So my original fraction then will get decomposed into, right? So I have the -2 from before. So here I have -2 plus what I got in the green part. So that's just going to be a over x, 4 over x, plus b, which is 3 over x minus 1. And there you have it. That's the answer. That's it. This can no longer be simplified. Right, so if you make a common denominator, add the fractions, what'll you get back? Your original equation of -2x squared plus 9x minus 4, that fraction. Okay? Yeah, this is nice. So you're decomposing it into simpler fractions, which when added give you that complicated rational expression. Okay, so both of these now were part of the first case where the denominator is just single linear factors. Next, what if your denominator is one that has repeated linear factors? So when you have a denominator of repeated linear factors, so for often when we factor something, we get something like x squared times x minus 1 or x times x plus 2 squared, right? When you have a case like this, like look at this one for example. You have x cubed and then x minus 1 squared. So what's x cubed really? It's just x times x times x. And what's x minus 1 squared? It's x minus 1 times x minus 1. So technically, you know, you have 1, 2, 3, 4, 5 elements which make this up. So you're going to end with 5 fractions, okay? And the way it works here is whatever that exponent is, 3, right? You have that many of those terms. So you have that many fractions for x. And then you start with exponent of 1, and you go up to this exponent here. So x to the 1, x to the 2, x to the 3. And then for the x minus 1 squared, you have x minus 1 to the 1, x minus 1 to the 2. Right? Yeah. So, and then, you know, the letters, you know, you just run through the alphabet. Right. So, here when you factor this, you get x times x squared minus 4x plus 4. So let's see, we're going to factor a little bit more. We're going to get 3x squared minus 5x plus 4 over x times, what does that factor into? X minus 2 squared. Okay, so how many total fractions are we going to have here? 3. 1 for the x and 2 for the x minus 2. So I have 1 for the x, and then I have an x minus 2 and an x minus 2 squared. All right, so always start with an exponent of 1 and just go up until you reach your exponent.
Is there any situation where you should be subtracting or you always add?
You're adding because then the constants will fix for the negative. So A, B, C. Okay? So remember, until now, all of these denominators are still linear. Okay? So if you look inside the parentheses here, they're all linear. X minus 2, x minus 2x. All right, same situation. I'm just going to multiply the whole thing by the common denominator. It's the whole, right? Okay, so everything cancels here. X's cancel here. X minus 2 cancels with one of these, and both x minus 2's cancel there. So let's see what we have. We have 3x squared minus 5x plus 4 equals A x minus 2 squared plus B times x minus 2 plus cx, right? Okay, so same situation. What can I plug in to make, you know, some of these, right, 2. Let's plug in x equals 2, and when you do that, for the first one, I get 4 times 3 is 12, plus 4 is 16, minus 10, so 6, right? 6 is equal to A times 0, plus B times 0, plus 2C, so how much is C? 3. And then what else am I going to plug in? X equals 0. When I do that, I get 4 equals 4A plus 0B plus 0C. So how much is A? 1. Now I still need to solve for B. Okay? Just because I ran out of numbers to make, some of these terms 0, it doesn't mean that I can't just plug in any old random number. I could plug in x equals 254 or x equals 1. So let's plug in x equals 1. You can plug in anything. Okay? When you do that, so when we plug in x equals 1, what are we going to get? 3 plus 4 is 7, minus 5 is 2, right? Equals A times minus 1 squared plus B times minus 1 plus C times 1. So basically 2 is equal to A minus B plus C. We already know A and C, right? So 2 is equal to 1 minus B plus 3. How much is B? C was 3. You get it? How much is negative 1?
2. The way we have it.
2.
Yeah.
All right? So 2. Long weekend, it seems. Okay, so now A is 1. So 1 over x plus B is 2 over x minus 2 plus C is 3 over x minus 2 squared gives me my decomposed fraction. Okay? So if one of these variables, ended up as like, instead of 2, let's say you got 2 over 5, right? How would you write that? So it'll be 2 over 5 x minus 2. You see what I mean? All right? Like instead of b equals 2, suppose it was 2 over 5, right? And that's how you write it, okay? We're going to be elegant and sophisticated. Okay. Now, the last case is if you have a denominator with prime quadratic factors. So in each case, you just factor the denominator and you see which of the 3 cases it matches with, and you just you follow the steps accordingly. All right? Now, in this case, when you have a prime quadratic factor, like something like this, right? One of the factors here is x squared plus 1. That's a quadratic which cannot be factored. The denominator will just stay as x squared minus 1, plus 1. In that case, the numerator can't just be a simple constant. It has to be a linear expression. Ax plus b, bx plus c, and so on. Okay? So whatever degree the denominator has, think of it that way. The numerator should have a degree 1 less. Does that make sense? Okay. So look at this one. Here I have x cubed minus x over x squared minus 3 squared. And you can't factor anything from here, right? So how many fractions am I going to have? 1, 2, 3, how many? 2. What will my denominators be? X squared minus 3 and x squared minus 3 squared. Okay? Now, because this is quadratic here, the numerator has to be a linear factor. Okay? So it'll be ax plus b. this is the same. Okay, we don't look at the square on the outside. We look at what's inside the parentheses. Again, it's a quadratic prime factor, so it's going to be cx plus d. You just run through your letters, like I said. All right, so if there was another one, it would be what? Ex plus f, and so on. Okay, and it's very common to go like at least through f. Okay. All right, same situation. Multiply by the common denominator. Everything cancels here and here, and only one of these factors go away. So what do we got? What do we have now? Now this one is a little bit different, okay? But I think it's of the different types, this is my favorite. So look at what we have here: x cubed minus x equals ax plus b times x squared minus 3 plus cx plus d. We're going to FOIL this here. So we have x cubed minus x equals ax cubed minus 3ax plus bx cubed minus 3b plus cx plus d. Okay? Now what we're going to do is we're going to group by degrees. Don't freak out. Okay. So the first one is going to be the term with the terms with the x cubes, right? Which we only have one, right? So it's just ax cubed. Next one is everything with the squares, which is just this, bx squared. Next, we take everything with x, so minus 3ax plus cx. Next, negative 3b plus d, the constants. All right. And just look through and see which one of these you can factor. The only thing we can factor is from the green, the x from that term. So let me just copy these over. All right, so from here, it's going to be plus negative 3a plus c times x. Right? I just factored out the x and I just put it on the right to be consistent. Huh? Well, you only have one x squared term and one x cubed term. No. We don't want to do that. Here's what we're doing. Remember, we're grouping by degrees. We don't want to mix the degrees. All right? So minus 3b plus d. Now, this is my favorite part. You match term with term. So for example, here you have the cubic term, right? Ax cubed. Now on the left side, do you have a cubic term? X cubed. What's the coefficient on the left side? 1. What's the coefficient on the right side? A. That means 1 equals A. My God. It's just amazing. So here you take your x cubed term and your x cubed term here. Okay? And you match up their coefficients. The coefficient on the left is 1. The coefficient on the right is A. So you just say 1. A is equal to 1. Yep. Now, let's look at the x squared term. Okay, look at the x squared term. What's the x squared term on the left? There is none. That means b is 0. Now look at the x term. Here's the coefficient here. What about the coefficient on the other side? It's a negative 1. So negative 3a plus c is equal to negative 1. And what about the constants? There are no constants here, so negative 3b plus d is equal to 0. Meaning, now let's just solve these. What's a? A is 1. So negative 3 times 1 plus c is equal to negative 1. So how much is c? These 2's are confusing us today.
That's like it's more than 1, less than 3.
And what's d then?
0.
Right. If b is 0, then d is definitely 0. Now I got all my constants, right? So I go back and write my fraction. A is 1, x plus b is 0. So x over x squared minus 3. Does that make sense? Plus cx plus d. C is negative 1, d is 0. So I just have negative x. I'm sorry, c is 2. C is 2, d is 0. So it's 2x over x squared minus 3 squared. And there you have it, ladies and gentlemen. C equals 2. Okay? That is amazing. So this homework
Is due on Friday. That's good.
right, so A period is due tomorrow.